All right, let's make a map. What I have here in the first map are the two classified medium household income data sets that I'm going to show in the final layout. I've added a state outline just to give a really faint sense of where the states are. I just got it from the Living Atlas. In map 2, and I turned off the base map because we don't need it, and added a projected coordinate system so that it doesn't distort the northern states and spread them out. Here's the second empty map. Remember, to have two different displays of the data sets, you have to have separate maps for them. So I have named these what they are, and I'm just going to go ahead and copy the natural breaks into the second map. And force it to draw by zooming in on it. Okay, no offense to Alaska, Logan. So I can turn this guy off. Okay, for the layout, I want to make sure I've got room for both data sets and a histogram for the legend. So let's bring in and then we're going to insert a map frame, and we'll draw one up here. That's what I'm looking for. That didn't work. We don't want to zoom to that layer. I'm going to use the shift key to force zoom to the area that I want there. Come on, finish drawing. So in this guy, hopefully we can get it to draw. There we go. All right. And we're going to end up having to change that that zoom. So here I'm zoomed to about 35 million. Let's go over to this guy. And in the general, we can change this. Let's change it to 40 million. There we go. Okay. All right, so there's our first map. Let's check out the proportions and the size here. Going into the properties of the frame itself, we can see that it's, let's make it 6 inches wide by 4 inches tall. So it's nice round even numbers. Okay, and then we're going to insert a second map frame, pulling from our other data set, and use the snapping feature to get that in there. And then we'll go into the properties and just make sure it's 6 by 4 exactly, so they're the same size. Okay, and then remember that you can go into the properties here and we can force it to constrain by linking the map frame center and scale. And it just automatically pulled from the other map frame, so they should be the same now. For this guy, we can turn off the topographic map, and then we need to go in and set our drawing on this. Wait, is that the right one? This guy. And I'm going to the properties, you couldn't see that. We'll change this one to 40 million as well, and force that to draw. Okay, and then I don't have the states in this one, Let's see if it'll let me just drag it up there. Nope. So I'm going to, whoops, copy it. And paste it. Okay. So it's funny, I turned off the topographic map, but it's still got the data credits in there. I'll refresh it and see if that goes away. But so by setting the size of the windows the same, and we set the scale and extent of the two maps to match, they should be an exact copy of each other. One thing that I think is pretty interesting, looking at the maps here, let's just dig into this for a second. This is our quantile map, and just look at the pattern that we see here. What do you know about this part of Utah that just rings kind of untrue? This is really desolate area, no offense, but it's in this highest class of median incomes. I think that's really interesting. And Elko County also, even in the other map, Elko County is still in the highest class. I don't know exactly what's going on there to drive that up, but even look at the difference between Cache County and and the rest of the Wasatch Front. I mean, it's 2 classes lower, and actually in, the class that's below the median or the average. That's pretty interesting. So, we know this area well. Here, it's putting us in a class, it looks like, so it's just so hard, isn't it? Like, is this class or is it this class? I think it's this class, which puts us above average, and then this is the average class, and this is below the average class. But on this one, well, I guess maybe it is just the average class. Yeah, and then this is below. It's just an interesting, for what we know about this area, it's interesting. And I think this forces you to think about that aggregation and how these averages of the median incomes for households, it's not an even distribution, right? So within the county, we have a very skewed distribution of household incomes that this represents. I mean, in Elko County, I think a very large proportion of these households are living in poverty. So I would guess this is a very skewed distribution of household incomes. So just to kind of reinforce what you were reading in the chapter 9. Okay, let's get back to making a map out of this. You're going to want to add text to explain what the classification type is here. This isn't an assignment about cartography or income and making a map about income. This is an exercise where I want you to demonstrate your awareness and comfort with classification schemes. So everything you add to these 2 maps should be talking about how the data are aggregated, how the data are classified, what this data means, what the classification scheme means, what the symbology means, what the distribution means, and you're going to want to show us the histograms. So let's see here, let's go to the natural breaks symbology. What I'd recommend doing is take a screenshot of this window. It's going to be different on everyone's computer how you do a screenshot. But get in there and grab this. Oopsie. And then I would save it as, natural breaks on your local drive. Okay, I saved my histograms as a PNG file and went ahead and exported both. Then in the layout, you insert, and under graphics and text, you can choose picture and navigate to wherever you saved it. And then you draw a space for it. The little snap guides are awfully helpful, aren't they? Okay, so you'll see that obviously the histogram itself hasn't changed. What's changed are the class breaks. Now this isn't a perfect way to do this because I just can't believe that ARC doesn't have a better way to do this. But between the quantile and the natural breaks, the class break numbers are pretty ugly. I think, for real map making and a nice formal map, you would go through and, let me show you. In the symbology, I would say that you'd want to clean those up. And so if this is, maybe round that to the nearest 700, and that's probably easier said than done. If we go back here, these are the upper values, so 48. What if we just made that 48,500? Make this one round that one up to 62. I don't know that that's a best practice, honestly. I don't know. I guess I would be curious to hear what you think about tweaking the numbers this way. 42. Oops. We're using the natural breaks or the quantile and then getting it within a ballpark. And maybe the way to do it is to not actually change these values, but just change the way that it's labeled so that technically the display is correct, but we've simplified the way we're labeling it. That might be a better way to do it. But I would guess that it's going to clean this display up quite a bit, only if we change the actual classes. So I think I would recommend doing that. It's anyone knowing quantile or how these classification schemes work, they're going to know that that's probably not true if you're dealing with such a random range of values. But that's what I would recommend. Okay, so what this layout needs is a lot of explanation, what these are, and a couple of annotations to demonstrate to me that you have thought about these classification schemes and understand the difference between the two that you chose. Make sure you're choosing a color ramp that makes sense for the data. So if it's just a range of income averages like this, you will want a sequential color ramp. If you're showing the standard deviation, you're going to want a divergent color ramp. And then, just make sure you're being careful with your alignments and scale and make sure your labels are legible, etc., etc. Questions, let me know.